Hello everyone, this is Anupam Mishra. I'm a solutions architect here at AWS, and the show you're watching is AWS Maker Studio. We launched this show about 4 weeks back. This is episode 4, and we feel like we've gone through a long journey. A lot of things have been built, a lot of products have been shown to you. There's a lot of interest. We have seen people from a wide variety of backgrounds joining, and seen a great momentum around it. So we feel that a lot of people are doing things which they wanted to do. That was the core purpose of this show. We wanted to inspire people to build things which they want to build and learn some of the technical concepts without going into too much details. Todd, do you want to talk about yourself?
Yeah, so hi, Todd Varland, Solution Architecture here at AWS. We're broadcasting live again from the AWS Makerspace here at our San Francisco office. And I'm sporting the ever so stylish Greengrass hoodie because today we went general availability for AWS Greengrass, which is the new relatively new AWS IoT service that we're going to talk about and get into in great detail in future Maker Studio episodes. And we had a launch event today at the AWS Pop-Up Loft in downtown San Francisco on Market Street. And so the AWS Pop-Up Loft is a storefront location for customers and partners and folks that are generally interested to drop in and have some snacks, have some drinks, non-adult beverages during the day, and to learn more about AWS. And so we had an event there today, and it was super fun. We'll put in the show notes a link to so folks can watch the broadcast from the event. But anyway, super fun event today, and something that we're going to get into in a lot more detail in future episodes. Sure. Trevor?
Very cool. So usually I say I'm here for the free food, but I do have a surprise for you guys. And just before we do our demo and make things a little bit more official, I have a surprise.
Okay.
Can you pass me my bag? Yeah. Thank you. So I wanted to take up the show just up a notch a little bit.
Oh.
And I want to see what you guys would think.
What do you got?
If during our demo we used lab coats.
Lab coats? Wow.
So I got them embroiderized. So if you look, they're actually pretty official.
All right.
Wow. Nice.
So how do we know which one?
It has our names.
Names in there.
Oh
Wow.
my, fancy.
Good job.
Oh my, okay.
Okay.
So if you look, it has our logo,
All
and
right.
it also has our names and Amazon Web Services on the side.
Nice.
Very
it's
nice.
pretty-
All right. Wow,
Yeah,
official.
so this is a tradition. Like whenever we start the show, we start with what are we gonna demo? What are the things which we're gonna build? We start with showing people how that thing works, or at a high level, what is that thing? And then we go into details of how can you make that thing possible? What are the different things you need to do? Great job, Trevor.
Yeah,
Yeah,
I
well,
really love
thanks,
it.
dude.
Pretty
This
cool.
is awesome.
Yeah, and we also have a special guest who will be joining us in some time.
Yeah.
And I'm pretty sure everybody will enjoy that segment.
Yeah, so definitely stay on the live stream because we have Sarah Cooper from our AWS service team. She'll introduce herself, but anyway, super glad to have her, and she's going to talk about lots of interesting things. So what are you going to show us?
Sure, yeah. Let's start with what we want to do today. So far, if you have watched previous episodes, you know we have built this robot. I'll show you how this works at a very high level. Let me show what it does first.
Okay, so are we showing on a Palm's desktop?
No, I think we'll just show.
You want to show your code?
I think we can just show the working thing first.
Okay.
So as you can see, what I have here is a leap motion. This is my hand, and when I move my hand, this robot mimics the motions of my hand. So let me keep it here, so you can see what's going on. This is a leap motion. Actually, I'll remove this thing as well. So this leap motion is detecting my hand movements, and as you can see, if I move it right, it goes left or right, it goes up and down. So So everything which is happening here is going through AWS IoT service. So we added a new feature to this. We wanted to show you how do you understand what cloud can do there? Because there were a lot of questions about, hey, I can directly connect this robot to my laptop. What does the AWS IoT provide us? So we wanted to show some of the cool things you can do with it. Let me start with one thing. So I've created a rule. Let me just run that for now, and I'll go deeper into that later. But I just wanted to show you.
Let me show the rules. Are you doing it on the screen?
Yeah, I'll show it later. But I just wanted to show. I have my phone here, and what I've done is whenever my hand goes up. So right now, let me send this as well. Okay. So whenever I am, I've written a script. What it does is whenever my hand is moving, it will send a message whenever my hand goes up. So let me just show that quickly. Just a minute. Okay. Okay, so it goes up. It should send some text to me. So I have two different things. That's why you were not seeing the arm moving. Cool. So it should send some text to the phone which I have here. And let me just a minute make some change here.
I want to believe you.
Yeah, and I'll show that. So 1 minute. I'm just changing the rule. And what I'll do is I'll move my hand.
So this is kind of like a cooking show. We're showing the end result to start with.
Yeah, like what happens here. So as you can see, my phone started beeping. There are some messages coming right now. What is happening is it's telling me that there's some action happened which I was checking in the cloud, and notify me when that action happens. So there are a lot of messages coming because I'm pumping a lot of data. But I'll go deeper into that. I just wanted to show you what are the things we're going to cover in today's episode. So I'm going to show you how this is happening end to end.
And how to do it yourself.
Yep.
Great. All right. So Trevor, can you show the data flow diagram? Because this will kind of set up kind of the next discussion points. So as Anupam mentioned, on the left-hand side of what you're seeing on the screen, there's the Leap Motion controller connected to his laptop, which then sends the data into AWS IoT, and then we're subscribing on the robot arm on the right-hand side with the Raspberry Pi. So that's kind of the direction of the flow. We also can send commands the other direction, which are telling the robot arm to move into whatever the various positions are. And so, as Anupam mentioned, why is a cloud-connected device more interesting than just a robot arm that's just, let's say locally connected to a laptop? And that's that we can do, processing in the cloud. And so if you go then, Trevor, to the next slide, I'll kind of talk over this. Is in robotics, the key ideas are you want to sense the world that that the robot is in, then you want to process, and then you want to act. And the really cool thing about AWS IoT is it provides the same core benefits that AWS we've been providing since 2006, and that is pay as you grow, lower total overall cost, no need to guess capacity, ability to move fast and change things up, focus on your business, experiment more, and benefit from kind of AWS pace of innovation. Like today, we introduced a whole new service, and now that's available to folks, and they didn't have to build all that kind of plumbing themselves. And so it's really kind of important to understand that what this means is that folks that want to make things, a person in their garage with an idea and one thing, as well as very large industrial projects.
So a very small, if there's a small initiative, I can use whatever services big companies are using.
Exactly.
So versus the old way, we had to actually buy, procure, which can take months and months, while you can do this now.
Yeah, and I think the thing that's really inspiring, about one element about AWS is that if you have a laptop and an internet connection and a credit card, you can have a data center that's at the same caliber as the best in the world. And so what AWS IoT is bringing to the table is if you're in your garage, you've got an idea, you got a laptop, a credit card, and an internet connection, you can have world-class IoT infrastructure. And so that's, to me, that's really inspiring and powerful. And I think that's kind of the message, part of the message we wanted to share today.
Sure.
So
how does somebody know that I need AWS IoT or not?
yeah, so I think there's 4 major kind of themes for AWS IoT, and let's see if I can do this off the top of my head. Help me out here. So the first one is security. So you want to be able to secure, and as we discussed in previous episodes, we went into kind of great detail about securing, the device, securing the communication. Next is process.
Yep.
We also want to communicate, and then we also want to manage.
Yep.
So today we're going to talk a lot about that processing part.
I missed one thing.
Yeah.
Cost and monitoring.
Yes. Well, those are very much elements that are visibility, cost awareness, lower total overall cost. Yeah, those are super important. So I think Anupam, I think where you're kind of going with this is, if you think in terms of there's choices even within AWS IoT.
Yep.
So from a connect and process perspective, there's different protocol choices. And so what we wanted to do is get into some of those details today. So there's choices of what, MQTT?
Yeah, so I think let's start with HTTP because by default, almost everybody has used HTTP either knowingly or unknowingly.
Sure.
So HTTP has been the protocol which is most widely used. There are a lot of revisions which have happened to it. Nowadays, people use HTTP 2.0 for a lot of use cases. And then when it comes to IoT, we say the de facto protocol used by most companies and most products is MQTT.
Mm-hmm. And
a lot of people were interested in one of our previous episodes. WebSockets also seems like MQTT. What is the difference, right? And WebSockets puts another paradigm to it. How does it compare with MQTT and HTTP? So let's try to demystify that. How do people understand where is HTTP good protocol, where is MQTT a good protocol, or where is WebSockets, or do they play together?
Mm-hmm.
So I can start.
Yeah, please go ahead.
So HTTP is a stateless. So what you do is you send a message and then you get a response back, and then every new message is either a fresh message or something on top of it. But essentially there's a large overhead which each packet which is sent from client to server incurs. There's a lot of handshaking happening. By handshaking, it means there's a packet which the client will send to server will send a response back that yes, you can send me data now, and there's a lot of other things which happen. But it's good to understand that HTTP is good protocol for reliable communication, where you have a lot of bandwidth, you have a lot of resources, and it's TCP based, so it gives you all those benefits. But when it comes to MQTT has different flavors.
Right. So, and also I think an important thing about HTTP is it's one direction.
Yep.
Right. So it's basically half duplex communication.
Yeah.
And it's often referred to as atomic. It is meaning that you make the request, you get the response back, and that communication session is then destroyed.
Yep.
And so it versus what you're about to talk
for
about.
MQTT, yeah. So one of the things which is unique about MQTT is the overhead which is incurred between for those small data transmissions are very low. So if you have small packets, for example, think of a million devices in the field which are sending you health status. You don't want to, if the health status is just a binary number which says 0 or 1, let's say alive or not alive, you don't want to send a much bigger payload than what the actual data is. So MQTT is very good for small size data which is coming and you want to receive them. It has a lot of flavors. For example, there's different QoS. QoS stands for quality of service. You can say what kind of behavior you want to expect from MQTT. For example, QoS 0 means the message will be delivered 0 or more times, which means there are times when you will not receive message. Similarly, QoS 1 means the message will be delivered 1 or more times. So there are different kind of things which different protocols can provide. Now let's move to WebSockets a little bit. So WebSockets are something which were introduced 4 or 5 years back. It's very relevant in day-to-day use because when we use chatting and applications which are pushing a message, the earlier paradigm was there will be a worker or a cron or some kind of script in JavaScript which is constantly checking with server, hey, do you have something more for me? The change which WebSockets bring is there's a constant channel which is open, and server can push those messages to the browser. So it's very good for applications where you want to alert a browser-based customer about an activity which happened on the server side without a customer asking for it. That is a big difference. And one thing which is unique about MQTT is MQTT is used on a lot of devices, but it's not used on browsers. So the way most browsers work, there are specific standards they comply to, and they slowly adapt new things which are happening. So far, I haven't seen MQTT directly adopted by browsers, but the way people get around it is they use MQTT over WebSockets, which means MQTT packets are wrapped in WebSocket packets. So the browser will think I'm talking WebSockets, but essentially they are MQTT. So there are different use cases for that. For example, I met some customers who are building chatting applications. So they have a big group which want to chat amongst themselves. WebSockets or MQTT is a pretty good choice for some of those use cases. Are there any questions, Trevor?
No, just they like the lab codes.
Okay,
Awesome.
Yeah.
Wow, great.
Yeah,
But
so
we can only use them for demos. We can't
Okay.
do it on
So we
our
have
own.
to
Okay.
take off.
Yeah, we gotta take them off.
All right. So let's kind of recap a little bit. So HTTP, single direction, has a lot of overhead. In other words, for every single request, there's like a whole bunch of bytes of data that get kind of tacked on to the data that you're wanting to either get or receive.
Yeah, sometimes let's say if you want to send 2 bytes, maybe the extra overhead you're having is 10 times of that, right?
Yeah.
So sometimes it's very, very significant expense and cost for the device.
Okay. And then it's a single transaction, one direction.
Yeah.
And so you make the connection, you do the transaction, and tear down the connection. Versus WebSockets or MQTT, where a connection is established, that connection is maintained, it continues to be open, and it's a 2-direction.
Yeah, it's reused many times, right?
Yeah.
So think of it like you invested something, and that investment is used over time, right?
Yeah.
Now there are use cases where MQTT. You don't think of MQTT or WebSockets as something which solves every problem. There are use cases where HTTP would be better. There are use cases where MQTT. But I think it's good to evaluate when somebody is building their device what protocol will be good based on the use cases they need to
So
support.
going back to what we just Trevor. So going back to kind of starting from what the business objective is that you're trying to solve, is that if you want bidirectional communication and you want to be able to do that quickly without having to make a new connection or wait for a incoming connection to happen, MQTT is a good choice. If, let's say, your connections are less frequent and you have a powerful computer to do the transport protocol, HTTP might be fine. So
Yep.
it really depends on what your business
Yeah, there are a lot of
needs
factors
are.
like frequency also plays into.
I was just
game.
going to ask, what would be like common use cases for someone on each protocol?
Yeah, go ahead.
I mean, maybe we can ask the audience a question on how we can, what would be a good use case for them,
Yeah.
I guess, in this kind of relevant
yeah.
situation.
Yeah, so I think if the like HTTP might be fine if you've got a traditional server and you're only, let's say, needing a connection infrequently and you don't want to have to maintain a connection, then HTTP is fine. So then I think the other kind of what came up in previous episodes, and maybe Anupam you can kind of touch on this a little bit, then is this idea of publish and subscribe.
Yep.
Right. So can you maybe share with our audience kind of what the concept, what the goals
Yeah.
are with publish and subscribe,
Yeah.
and how that relates?
Yeah, so this is a very common thing which any IoT device needs to do. So I mean, it's a buzzword. Some people call it like it's a very overloaded term. So let's think of a device which is connected to the cloud or some other servers. It always needs to either send some messages to the cloud or cloud needs to send some data to it, right? Those are the two possibilities which will always happen. Traditionally, it happens in a synchronous way where there's an endpoint in the cloud and there's a message which we send, and then similarly, if the cloud needs to talk, there needs to be a server which is hosted on the device and that is being talked. That was a traditional way. When PubSub comes, what PubSub means is publish and subscribe, which means the device is subscribing to certain activities happening in the cloud. So whenever those activities happen, device gets to know about them. Similarly, cloud can subscribe to different things happening in the publisher. So there's publisher and subscribe pieces, and there are different things which people can do with it. So for example, let's think of a use case. Let's say you have a home and you have.
Let's get the audience to give us a use case.
Let's. I mean, if you can, if audience can give us a use case where they would like to understand how does PubSub, how would a PubSub fit into that picture?
Yeah. So while we're waiting, so some of the design benefits or the architectural benefits of publish and subscribe is that when you have a publisher like Elite Motion and it's publishing to the AWS cloud, is the publisher doesn't need to know anything about what devices are interested in that data. So it's which means that the publisher can be quite lightweight.
Yep.
Right? So because it doesn't need to keep track of like, okay, who needs to see this information?
Who needs it? How will they perceive it? It doesn't care. It's just sending the raw information to the cloud.
Yeah. And then vice versa, the subscriber just says, this is the information I'm interested in, and it doesn't need to keep track of all the possible data sources. It just communicates with what's in this context is the message broker, which the message broker runs in the AWS cloud. It's a key component of the overall service. That's what keeps track of what devices are publishing in and what devices are interested in those bits of information.
Yep.
And so what it means is that on either end, it's relatively lightweight, and then the message broker in the cloud does the heavy lifting. And so that's a key kind of architectural benefit.
Yeah, is there any question from audience on this?
No, not yet.
Okay, so let me take an example which I was thinking. Let's say there's a home and you have a lot of rooms in the home, and then you have different devices within each home. For example, one is monitoring whether baby is sleeping or not. Maybe something is tracking whether a light is on or not. Maybe something is tracking your fridge is on or not. So what you can do is, if the topic is, let's say, your home name, and then you can have different subcategories within it. I mean, it will be called a subtopic. You'll create a slash. So you'll say my home slash room 1, and then with the slash you can say device 1, device 2, device 3. And then people can subscribe at different levels. So you can say, whenever something happens to my home, I want to know, no matter which device it is. So then you will subscribe at the topmost level of that topic. Similarly, you can say, there's a specific notification I want to receive whenever my baby monitor does something, for example, and then it will send you a notification. So what topics allow you to do is you can subscribe at what level of hierarchy or how much specific you want to be to a specific device, and then get messages and then act on those messages.
And that's a ideal segue to the rules engine.
Yeah. So
right? So how does so maybe you could just mention briefly how the rules engine played into the demo that you showed with the processing the messages, and then we can
sure.
Bring on Sarah.
So the demo which I showed, where I lifted my hand and it sent me a message, it used a component of AWS IoT called Rules Engine. What Rules Engines do is it is looking at all the data which is coming into the cloud, and whenever it finds a data packet which matches my rule, it can trigger some action. So in this case, I created an action called send a SMS to my phone, but it can be virtually anything. You can say run my custom code, you can say send my data to another database, and a lot of things. Now I think we should introduce our guest. She runs our Rules Engine team and a lot of other things. So let's introduce Sarah. Is she on? Can we put her on?
Yeah, you want to put the echo a little bit closer?
Sure.
Okay.
Hi Sarah, you're on. So I think one thing which our audience would like to know is what is your background? What do you how do you get involved in IoT?
Yeah.
Well, first of all, before we even start that, where's my lab coat?
Speaking of, it's not demo's over.
Oh yeah. Okay.
Oh no. Well, maybe I had one on during the demo.
Okay. Well, I'm gonna keep mine on. I think I love it. So, so tell us about yourself.
Sure. So I've been in IoT since really before there was IoT. Lab code's something I'm actually quite comfortable in. I started out as a materials physicist, working on nanomaterials, which are basically when you get so small that quantum effects start taking a precedents in material properties, you get these wonderful and wacky things. One of which is that you can generate power temperature gradients, even small ones. So in working on those materials, I ended up developing a battery technology that worked really well for remote devices. So you can kind of see it was physics and nano, and then you grew up into these batteries, and then you get to the point where now we're talking about devices. So I started a company that was based off of that battery technology, but focused on medical devices. So a pacemaker battery that would last as long as you do, built off the same technology. I was at NASA at the time that I was doing some of the work, and same basic foundational technology that's in something called radioisotope thermoelectric generators, RTGs. It's the things that send deep space probes and power them out. Lunar landers, the first Mars landers all had RTGs. Actually, the first pacemaker had an RTG. Like, they literally had plutonium cores. You couldn't leave the country with one back in the 70s.
Wow.
Is that the one with the flux capacitor?
Right? Yeah, exactly. Your own flux capacitor. So anyway, that kind of got me into connected devices, remote devices, pretty early on before there was IoT. And through that, I ended up doing I ended up selling that company, learned a hard lesson about Medicare reimbursement. Don't get into the medical device business until you've looked through the whole pathway of the business plan. But I then did some work in mining with the chemical additives business. The extraction equipment was all connected to the internet back in the early 2000s. So that was machine-to-machine technology. And then finally, after a stint back at NASA, got roped into getting into the software world, and really started to work hardcore on IoT and how do you connect the wonderful variety of devices that are out there in the world, and how do you make sure they can all talk and control and coordinate and synchronize, and kind of all the stuff the Rules Engine team's trying to work on. At AWS, I own IoT analytics, the solutions space. The analytics, the real foundation of that intelligence layer is the Rules Engine. We've got a lot of other wonderful components within AWS for analytics around real-time data, stream processing, and then moving that up into kind of higher level solutions as well, so our customers don't have to work quite so hard to build their own IoT platforms and applications.
Wow, thanks.
Long answer, but
Yep,
I've been around the block.
Sure. I think given your background, I think a lot of people would want to know, how does somebody go from an idea to a product, right? Like, for example, I'm thinking, it'll be cool to have something which does, let's say, automatic curtain, like opens my curtain or closes my curtain, or it could be any idea, right? I mean, you can probably share something from your experiences, but if somebody has an idea and they want to build an IoT product around it, what is the typical journey?
I'm curious, have you done this yourself? Have you, like, at home, have you built anything that you wanted to build out in your, I know you just moved to a new home, but just curious.
I do. I have some smart home stuff in my house. And then also, previously, I took a 1980s Power Glove, the
From
Nintendo Power
Nice.
Glove. Yeah, so I pulled out the cables and stuck in a Bluetooth module and tried to do the control of the screen remotely. It worked. The delay and the latency wasn't great. I didn't spend any time optimizing it. It was kind of a fun side project. But I love, pulling the guts, particularly out of retro equipment and IoTizing it. There's something that appeals to me about things recycling. Lots of technology concepts do that. From how do I get from that kind of a prototype into an actual product? There are multiple paths. It really depends on kind of where you sit in the world. If this is, as an entrepreneur, if you've got a great idea that you want to commercialize, or if you're part of a larger company where you've got an existing product that you want to connect to the internet and start taking a look at that. There's some similarities. One thing to consider: once you've connected something to the internet, people expect you to update it and make it, continuously improve. So you can no longer have a product that stays the same for 20 years. We expect that, given the pace of technology, whether you're an entrepreneur or a large company, that product is going to be upgraded and updated. You can get your autopilot with the click of a button and maybe the swipe of a credit card. And from an entrepreneurial standpoint, though, which I think is is a path a lot of people are looking at today. There's a big gulf between starting out and prototyping. A lot of people are using Raspberry Pis or Arduino boards to kind of get their idea. That's a good place to start, to kind of just see, if your idea pans out. Is this something that you would use? There's a wonderful company, Kyler olive oil farm. They do olive oil pressings and processing down in Paso Robles. And the proprietor, Greg's an old software guy, so he took all of this fancy Italian equipment and hacked it. He actually built Arduino PID controllers throughout it and raised his extraction rate from about 65%, which was standard out of the box for the equipment, up to 92%, which is amazing. When you have those kinds of advancements and you're working on Arduinos or you're working on Raspberry Pi, figuring out how you then commercialize that, not just from the idea standpoint, for which those systems are wonderful, but then how do you get to 10,000 or 50,000 devices to meet your first customer segments? And there are some folks over at Intel and some other organizations, there's some teams at AWS that work on these kinds of things too, trying to figure out how do we have development boards that get you into that first stage. But one of the first things I would, as the conversation around protocols works through, you got to start figuring out what other systems your device is going to have to talk to, and build that into the types of protocols you choose, the kinds of communications. If you want to use something, SNS and SQS, which are notification and queuing services on AWS, are great ways to kind of act as glue within a system. But you really got to look at your overall functionality from the ecosystem that your device is going to be working into. Even in consumer IoT these days, these things come together and they've got to work together. As smart home technology is starting to learn the hard way.
Yep.
Yeah.
Trevor, are there any?
That would be my sort of piece of advice. Look at where it's going to be in 3 to 5 years and architect for that. Don't just architect for what the Raspberry Pi has in front of you.
Sure. And for people who are watching, if you have any questions, feel free to send us on chat and we'll ask the same to Sarah.
Yeah, I think you're getting more responses than we are, Sarah. We got a G. Pally says hi from Argentina.
What up?
Awesome. So what kind of, there's been a lot of changes, in the industry in the last, even, 2 years. What are things that folks should be thinking about, and, about what's kind of ahead, or, planning wise, or just kind of think, projecting into the future a little bit. What do you see?
There are a lot of challenges that start arising, both technology as well as business challenges that start arising when you start moving from kind of single connected products, where most of the analytics you're doing are over a population of devices. And when you move into ecosystems like airports, where you have multiple processes, say baggage claim and baggage transfer, plus fueling and catering, all that have to happen on the tarmac in order to get a plane to turn around with, optimum timing, which is basically how airlines make money these days. If they can turn around that plane a little bit faster, they'll be in the black. So those kinds of, critical business decisions require coordination across many thousands of devices who have different functions from different manufacturers and are often controlled and owned by different members of the value chain. So that's a lot of layered complexities. There are interoperability challenges. How do they all figure out what their role is in the process? If you have to script all of that, that's a lot of spaghetti code. If you can figure out a way where you can, from top down, understand what functions are and allow the device that is most optimally either geographically placed or logically placed, i.e. it has a coherent set of inputs to make those decisions. That sounds more AI than it necessarily needs to be. There's some interesting work being done in that space. But basically the layered complexity is starting to build in IoT, and there aren't as many technologies or companies who have really gone through that digital transformation to be able to address those challenges. Even who owns the data, and how do I share an insight? A bag's been pulled off the line for TSA to do an extra check. How do I let the airline know that that is Sarah's bag and she's a platinum frequent flyer, and so therefore don't let the plane leave without it? And that's really important.
Interesting.
My favorite use case.
Okay. So,
but yeah, go for it.
So the AWS Rules Engine, does that play into these types? Is that kind of what you're alluding to?
It is. The Rules Engine is a foundational piece of a couple of really core IoT components. One is just the intelligence. The Rules Engine has sort of three core functions. One is routing, as you mentioned, getting your message from that message broker to any other service on AWS. That's kind of the basic core, doing that fast, doing it cheaply, doing it quickly. That's really the core basis of the Rules Engine. But Rules Engine also does data transformation, because just because you throw a ball doesn't mean the other side's going to catch it. So if you're sending, we just announced a connector to Salesforce IoT, so you can move your data directly from the message broker into Salesforce. You have to do a data transformation of your raw message to send that into Salesforce, and the Rules Engine does that too. So it's kind of that first intelligence layer. It's the first place where you're inspecting your messages to see what the content is, and then deciding on that content what you want to do. So there's an actions component to it, as well as that initial data transformation and filtering capabilities within the Rules Engine. So it sounds surprisingly simple when you first kind of go, oh yeah, of course I can write a rule, I can inspect my data and then decide what I want to do. That makes sense. But when you look under the covers, there's a lot of flexibility and power in that product.
And AWS allows
And they're awesome.
folks to do it at scale, securely at scale.
Yeah. That's securely low latency at scale is really the art form around all of IoT, and that's why not all IoT is created equal as well. These things don't look like typical. It's almost a reverse, CDN, content delivery network. A lot of the internet infrastructure and a lot of data center and cloud infrastructure was built to deliver content from the cloud out to mobile devices, laptops, desktops, satellite campuses. And IoT, you reverse that flow. So all of this data is coming off of potentially high frequency devices like jet engines, or even periodic connections, event-based connections. You don't know when some of these things are going to connect, and when they do, they can send tons of data or just a few very critical messages. Yep. Nuclear meltdown in 5, 4. You want to get those messages.
Yep.
So anyway.
Sure. Thanks, Sarah. Are there any final questions for Sarah from audience?
Doesn't look like it. Looks like we.
That's great. I'm completely coherent then.
Awesome. That's great. So should we dig in and actually show folks what the Rules Engine actually looks like? I'm gonna give you the power.
Sure. Here. Yeah. So let's look at what Sarah just talked about and see what does it mean, what does it do. So
thank you, Sarah.
Thanks, Sarah. Stay on in case we have any questions. But we're actually gonna show some of the work from your awesome team.
Sure. So let's start with where we left the last episode. So last episode, I was we got you on the screen. So awesome. Yeah. Okay. So I was in Canada. We wrote some script together. I can quickly show you, and this will be available on the link which we share. But this was a simple script we wrote to detect a hand from Leap Motion and send this data into cloud. It's probably So if we look at line numbers, it's probably 20 lines of code, and it does it's detecting the data from Leap Motion and then sending it to cloud. Let's run it. Now if we run it, it's a Node.js script, so I just ran. As I move my hand, it's sending a lot of packets into cloud. As you can see, it's sending x-axis, y-axis, z-axis, and my hand position, which is closed or open. So as I close, it gets 1. As I open, it gets near to 0. So now just resuming from that place. Now what we want to do is we'll go quickly into AWS IoT. and we'll quickly check whether this data is coming to cloud or not. So I'll subscribe on a topic called pound, which means everything which is coming will start appearing to this guy. And if I move my hand, it's getting all the data which is coming from my hand. So now that this connection is working, and if you want to know about how this was done, please watch our last episode 3. We have gone step by step into each things which we had to do to make this possible. Now that it's working, what we will do is we'll go to a rule and create a rule. So right now I don't have a rule, so I'll create a rule. Let's call it give it a name. Any names, Trevor?
Let's see. What would the chat like to name this? I'm thinking topic face.
Topic face. Okay.
It's a call from there was a same survey. I think it was England. That's what should we name this boat?
Oh.
And the entire, I guess, like people in the world, or I guess in English, let's call it Bodie McBoatface.
Oh,
Okay,
okay.
alright, so
Okay. It's topic face. Okay. So the rule, the name, it's just for you to understand what this rule does. So you can give a name which you like, and you can describe it. So later on you remember what this rule was. So in our case, this rule is telling us whether device is above a certain position. Maybe you don't want a certain action to happen, and you want to immediately get alerted when that action happens. So in this case, we are thinking that a device, if the hand is too high, we need to know that something wrong is happening. So I'll say alert on hand too high, and then you can you can look at the data. So if you look at the packet which I have, it's a simple JSON which has 4 parameters: X, Y, Z, and hand position. So you can query any of these parameters and say whenever a specific parameter is more or less than a certain thing or equal to a certain value, then you want to trigger this rule. So think of it as like a traditional SQL. So there are 3 things we provide here. What is the attribute we want to extract from that? If you don't know what to extract, you want to send the full payload, you can just put star, or you can give one of the attribute names. Same goes for topic. So if we go to the topic which we were talking, I think we slowly touched on that, which means if you have a big topic name with a lot of slashes, if you give only the first subsection and put a pound at the end, that means everything from that topic will be subscribed. And so in this case, let's go back to the screen. If I put a pound, that means everything is coming, but if I put a topic name /pound, that means only that data would be coming. So let's start with this. I'll keep a very simple condition because we are just showing you what IoT can do. So let's say y, let's look at the parameter name. Our parameter is called y-axis, and we'll say whenever it's greater than, let's say the value is 100, sometimes it goes up, sometimes it goes down. So let's see how it goes till 400 something. So let's say when it goes above 480, we want to send a message, let's say greater than 480. And then the next step is add an action. When this condition is matched, what do we want to do? So there are a lot of things. This is the Salesforce integration which Sarah was touched on. It allows you to send data even outside of AWS. So let's look at SNS notification. So
yeah. So I want to pause here for a second. So, as a coder, the fact that you can just click a radio button,
Like a plugin from in our section.
a connector to all these different services. I mean, this for me as a kind of a person that likes to make this is like amazing, right?
yeah,
So,
and the amazing reliability which comes with it, because you are not debugging each and everything. Like what happens if my message were not sent? What happens if it was retried? What happens if there's a bug in the software which I used? All of those things are coming along with this.
yeah, and you didn't have to code any of this up.
Yeah,
So
so
just
I'm
literally-
just selecting some things here. I mean, I feel like it's a little bit too easy, but if I select send a message as an SNS push notification, hey Trevor, you want to switch to my screen?
Yeah, let's see. We might have a couple chat questions here.
Sure. Let's pause and take some questions.
Let's see. How about Flying Spaghetti Mon? Do you have any questions? How about you, Jipali? Or let's see, Christopher Aberns.
Have they written their questions?
They just did some call-outs and saying hi.
Okay.
Okay, cool.
Sarah, do you have any questions since you were like an on-call guest host?
About what?
I take.
So far, I'm following you quite well. Thank you.
Awesome.
That's
All right.
good for you, Anupam.
Cool.
Cool,
All right.
awesome.
So you've selected send an SNS message.
Yeah, so there are a lot of options here. We can run a custom code, which is our service called Lambda. You can write a code which will get this payload, and you can do a lot of things with that payload. But if you're talking about SNS, we'll just send a notification whenever the condition is true. So I'll say configure action. Finally, it tells me which SNS target should the message be sent to. So I've already a lot of targets. I created some of them, but I'll use the one which is my phone, and then I'll select a format. I mean, either I can send a JSON or the raw message, which is the message which was received, and then a role. A role allows AWS IoT to talk to SNS. So by default, we don't allow services to talk to each other, but you can create roles which give certain privileges to specific services.
Yeah. So pausing there for a second. So this going back to if you watch one of our previous episodes where we went into the security aspect of AWS IoT, the ability to identify individual devices uniquely and manage at a relatively granular level what they can or can't do is surfaced basically right here.
Now, so one question is, how would it provide some, let's say, leap motion? How would they provide some driver API for accessing the hand positions?
So
going back a little bit,
can you read the question once more?
David MCO65 has a leap motion.
Yep.
Yeah.
And did they provide some driver API for accessing the hand positions?
Okay, that's a great question. So this is something which we covered in our episode 2. We had a guest from Leap Motion. He showed us how Leap Motion works. And then episode 3, we actually coded this. So let me quickly show the code. I'll not go into the details of the code, but I can show you because there's a question here.
Yeah.
And
so while Anupam is bringing this up to show, so Trevor, are we seeing? Yeah. So we've got actually 2 different robot arms right here. So we've got what we call our Pro and our Classic. But we have a single Leap Motion controller. And one of the things to answer the question that you can use the Rules Engine to do is you can send the same telemetry information into the AWS cloud, but use the Rules Engine to transform the kinematics, the mechanical aspects of that arm, so that each of these arms, which have very different physical characteristics, to respond appropriately, but from the same data source. So that's actually I think a great example of how to use the Rules Engine to transform data depending upon the different factors of your target devices.
Yeah, so it simplifies a lot of things because your devices are very, very dumb. They are just receiving a message and acting on it, or sending the data which they are sensing. Every intelligence piece goes into cloud and makes those devices very, very simple. You don't have a lot of calculations, a lot of bugs happening there. You're just getting the data and sending it to cloud, and everything comes together, and then you make decisions out of that.
And they were saying, is it only JavaScript? I mean, there's other.
Sure. Yeah.
SDKs.
Can you switch to my screen? I'll. So to answer, who was the person who asked?
It was just David MCO65.
Yeah,
there is a SDK library.
Yeah. Hey, David. Leap Motion has multiple SDKs. In our example, we used a JavaScript SDK because it's simpler to start with. From
your perspective.
From
my perspective, Python.
Yeah, I mean, I think I shouldn't be biased there.
David's actually a Java guy. So.
Okay, Java guy.
Yeah.
Java. Yeah. So definitely there's a Java SDK. So what you can do is similar to the top line you see here. I'm importing a library called Leap.js, and then once I import this, I have a lot of controls available in my code. I can say frame.hands.length, which means how many hands the Leap Motion is seeing. Similarly, I'm saying hand.palm position, direction, everything. So I think all that data can be grabbed. Same thing can be done in Java as well. So in the interest of time, I'll not go into depth. I'll just quickly show how this rule is created. Finally, I'll say add action and create rule, which means this rule is now acting like it's available right now. So it's already starting to act on data. So as soon as any data which comes, which matches this rule, so I just ran my code again. As soon as it goes above 400, let's see.
And this is detecting your arm going up and down from the Leap Motion sensor.
So so I'll just move it up. Let's see. Let it send up. Okay. I think yeah, just keep it like that.
And for the folks that I guess didn't see in the other episodes, this is going to
Yep.
US East and back over here.
Yeah, so it just went to 500, and you can see like I'm starting to get so many. I don't know where to show it, but I think it's a little bit too far. But you can see there are a lot of messages which are coming now. So the reason a lot of messages are coming are because we are triggering this event on every message which comes, and the rate at which I'm sending messages is a little bit too much. So it's sending a SMS for every message which matches that. So that's the simple piece. The lot of powerful things can happen when you can add multiple actions. So when a rule matches, you can have a notification go out. You can also transform the data. You can also update some systems. So possibilities are limitless.
Yeah, and if you ask in chat or even like on Twitter us or email us, we can show you guys live on the next episode or this episode. Or
So should we talk about the next episode? And
I think one thing I want to mention before that is for people who have use cases in their mind which they want to build, we would love to know about them because we want to transform this show based on what our audience needs. So it's great for us if you can tell us what are the things you want to see. Like let's say I really liked the example David had. He had a league motion and wants to try Java. Maybe we can focus on that in one of our bonus episodes or future episodes. So do let us know what are the things you would like to see, and we'll make it happen.
Yeah, and so next time you can ask us like what IoT devices you guys have at home. Like let us know on Twitter. Let us know on our email, which is
AWS-Twitch@Amazon.com. That's our email address. You can also reach out to us on Twitter. Our Twitter handles are shown below the feed right now. You can just tweet us and we'll respond to that.
Yeah, great.
Yep.
So I want to give a little preview for next week. So, and I just want to shout out for Sarah. Thank you for joining, Sarah. Super awesome to have you on. So next week's guest is going to be a person from the company Robotis. And Robotis makes the servos that we're using in our robot arm device and some communication equipment. They're doing some really interesting things that we've taken advantage of with AWS IoT. And so we're gonna have a person on from Robotis talking about how they're enabling things like lots of contestants in the Robo Cup, which is an annual event where they have small kind of humanoid robots that literally play soccer autonomously, and so how they're contributing.
It's the nicer version of the Robot Wars. Or
it's the kindler, gentler version of Robot Wars. So anyway, we're going to have somebody on from Robotis next week,
and we'll go very deep into this piece. The robot you are seeing, like what is the code running here? Who is powering this robot?
Yeah, so we're going to go much deeper into the hardware side of things as our next and fifth episode of this season. So do you want to share kind of what the kind of go forward plans are?
So we hope that we'll be able to show you end to end how this device works by next episode. And then if we get more questions, we'll go into specific aspects of that depending on how we see what kind of questions come. Mm-hmm. But if not, we will take a pause for a few weeks and then we'll start again.
And in that pause, send us as much information you guys can, like questions, devices you're using. I mean, we're getting some questions in chat, but the more that we have, the more material we'll have to show you guys on the episodes. Yeah,
it's great to know because we didn't start with a very specific thing we want to build. We just wanted to start letting people build whatever they want, and we just want to take your feedback and build it. Yeah. And before we end, I also wanted to give a shout out to Justin.
Justin. So come on screen, Justin. So
he has been.
So behind the scenes, Justin has been providing a lot of support for us, trying to have an awesome.
And his colleague Gina,
of course, Gina. Yes, and that the whole team in AWS Developer Marketing, big kudos there. And so, but I did want to share that we're thinking that machine learning
that'd be cool.
as a big theme for kind of our next series of episodes, which are going to start up in late July. There might be some bonus episodes in between, so stay tuned. But what we're thinking is machine learning. So taking this robot arm and moving it to the next stage of being able to operate more kind of autonomously. Not quite yet Terminator or Skynet, but something that's a little bit more autonomous is what we're thinking.
Goal.
Yeah.
That's the goal.
That's the goal.
Yeah.
So add machine learning. So we've got some ideas. We'd love to hear suggestions from folks who've been watching this. But anyway, that's kind of our high-level theme idea for the next set of episodes.
Sure, and join us next week. Thanks a lot for watching. Really appreciate all the feedback, and do tweet to us if you have any questions.
Great.
Thanks again.
Awesome. Thanks, everyone.
Thanks, everyone.
And awesome, Trevor. That's really,
For sure.